What's up, mathletes? Welcome to 9.4.1 day one. Guys, we're on the end stretch. We're getting kind of to the end of what we're going to be learning this year. But here's the thing. Our EQ today is, how can I represent the system of inequalities? How can I represent the system of inequalities? It's a mouthful. We've done systems of equations where we got specific answers or non-solutions, but how do I represent a system of inequalities? Well, first, let's look at this. Below is the graph for y is less than negative 2/3 x plus 2. So we see that. So we go to 2, go down 2 over 3. Look at that. That's the slope. And it's dotted because, or dashed, however you want to say it, because it's just less than. So it can't include values on the line. But what happens when we have a system, so we have more than one equation to graph? Well, we're going to look at y is less than x squared plus 2x minus 3. We talked about graphing quadratics just the other day. So now, or graphing quadratic inequalities. So now let's look at this. First things first, we're going to treat it like y equals x squared plus 2x minus 3. And I'm going to go over here. Let's just draw what we know. First of all, what kind of a shape is this going to be? Well, it's a positive x squared, so we know it's going to go up like that. Okay. What's our y-intercept? We already know that as well, right? 0, negative 3, because of this right here. And what's my x-intercepts? Well, that's going to be a question we got to answer here, but we do know our y values at least. And let's go ahead and work out our generic rectangles. In fact, why don't I posit, you guys work it out too. How about that? You know where stuff goes. It's good practice. You should be experts at this by now. Remember, once they're equal to 0, just write the opposites and you have your x values, right? And go ahead and find your line of symmetry, right? Which will give you your x value of your vertex. Once you have that x value, you got to plug it in, get the y value. Don't forget that stuff. And I just plug it into the factors now. It's so much easier to me. All right. I'm about to unpause it because I've worked all the way through it. I encourage you guys, if you're practicing on this and actually doing the practice, you should hit pause now and wait till you're done, then hit play. But here we go. Boom. So we have a y-intercept of 0, negative 3. Let me go there. 0, negative 3 right here. We have an x-intercept of negative 3, 0, and 1, 0. Vertex of negative 1, negative 4. I'm going to have to kind of make up my negative 4 down here, right? So negative 1, negative 4 is going to be out right here. Again, that's the line of symmetry that goes straight up. So we know that this point's going to reflect over to negative 2, right? And what kind of a line is it? It should be dashed. So do a dashed line. Dashed line. I'm getting better at these. And if you ever accidentally draw a solid line, just make sure you go over here and mark dashed. If somewhere even pointed, mark dashed. Somewhere, you could write dashed. Just something to let me know it meant to be dashed. You just didn't draw it, and we don't really want to erase it and do it again. Also, what does it say? It says less than. So that means I'm going to put my pen on it and go down, which is on the outside, right? All right, so now that we've got it graphed, and I generally just draw in, kind of the square represented here. The area where both are shaded represents the solution set for the system. So let me go ahead and be a little more explicit about that. They're both shaded right here. Uh-oh, my pink pen's kind of mixing with the blue pen. It's more of a violet now. But there you can clearly see what the solution set is. So now what does it say? It says pick a point from this area. So let's pick a point. You need to pick a point from here. Remember, it can't be on the lines because the lines aren't included. But let's go ahead and pick, I don't know, 3, -1, right here. That's clearly in the solution set. So I'm going to pick 3, -1. This should work. So here's what we're going to do. We're going to go down here. And I should be able to plug in my x and my y values and get true statements on both equations. So let me pick the point. All right, pick 3, -1. And remember, this was y is greater than or equal to -2/3 x. And this was y is less than or equal to x squared plus 2x. So plug in the values where they go. So I'm going to plug in my -1 is greater than -2/3 times 3 plus 2. And over here, I'll end up plugging in -1 is less than 3 squared plus 2 times 3 minus 3. Let's figure out over here. So we're going to have -1 is greater than, well, these 3's cancel out, and I'm just left with -2 plus 2, which means -1 is greater than 0. Is that true? Okay, I just figured out a typo. Are you guys ready for this? This should have been less than. What? I was like, something's wrong here. It's not greater than 1. That is wrong. It's less than. But as I always tell my students, I leave these in to show you, hey, sometimes I got to figure out things too. If something doesn't make sense, stop and evaluate it. Because that's the first thing I did is I was like, wait, something's off here. -1 less than 0, because this was less than. If you look up here at the original equation, it should have been less than. If you look at the graph, it was less than. So I was like, wait, greater than, something's off, boom. Is -1 less than 0? Yes, it is. And now I know to tell everybody to mark that correctly. Now, thankfully, I wrote this one in right, so there is that. Here we go. -1 is less than, let's see, -1 is less than, what's 3 squared? 9. Plus 2 times 3 is plus 6, minus 3. Let's see, -1 is less than, what's 9 plus 6? 15. 15 minus 3 is 12. Is that true? Yeah, -1's a lot less than 12. That's true. So these both are true. Now I want to show you what would have happened if we would have picked a point anywhere in one of these regions. If I picked a point in this region, what's going to happen? It's going to be true for the line, y is less than -2/3 x plus 2, but it won't be true for the other. Let's pick a point anywhere up here where it's going to be false for both of them. So I'm going to pick a point, I don't know, let's see, 4, 0. So let's test the point 4, 0. What's 4, 0 going to get me? I don't know. I'm going to have 0 is less than, I'm going to write that right this time, -2/3 times 4 plus 2. All right. So I'm going to have 0 is less than -8/3, right? Just multiply straight across, plus 2. And 0, by the way, this is 0 is less than -2, and is it 2/3? Yeah, 2/3 plus 2, which is 0. You can't see this. Let me scroll up. Move this out of the way. 0 is less than -2/3. Is 0 less than -2/3? Nope, so it doesn't work for that one. let's try it over here. Should be 0 is less than 4 squared plus 2 times 4 minus 3. I think we can all see that that's going to be wrong. 0 is less than 16 plus 8 minus 3. Those make 5. 16 plus 5 is 0 is less than 21. That's not true either. So we see how it makes it false. We're going to actually explore this concept more in a future lesson. But you guys are seeing here, we just graph them both on the same set of axes. We find the solution region where they're both true, and we can pick a point out there and test it. With that said, get your homework done. Peace out.